Hello students, in this lecture we will take new concept of first chapter, that is a potential gradient. So for potential gradient, one of the question is asked in exam, show that E is equal to minus grad phi, or derive relation between E and phi. So we'll derive this expression E is equal to minus of grad phi. So potential gradient, it is defined as rate of change of potential with respect to distance and measured in volts per meter. Rate of change of potential with respect to distance. We have potential difference phi is a work done in a moving a positive charge from one point to another in an electric field. So phi is given by minus of EDL. For shorter element of length del L, along which E bar is constant, we will get incremental potential difference del phi. Okay, so this is a diagrammatical representation, and this is a del L, this is a theta angle, and this is a electric field. So here we can write this equation above 1 in del form, that is a del phi is equal to minus of E del L, minus of E del L. dl we can represent it as a del L, which is a differential length. Then if we will denote theta is angle between E and del L, then del V is equal to, we can write minus of E del L cos theta. Therefore, del V upon del L is equal to minus of E cos theta. Okay, so this del L goes to this side, therefore we will get minus of E cos theta. So this is a simply vector analysis when A bar and B bar, or A and B are the vectors and theta is angle between them, then formula is a AB cos theta. Similar to here, E and del L dot product, we can write it as a E del L cos theta. Take del L this side, we will get this equation. Then we have to take limit del L tends to 0. Therefore, del V upon del L is equal to minus of E cos theta. Then dV by dl is equal to minus of E cos theta. That is in differential form. This del is replaced by d. Okay. Here dV by dl indicates a rate of change of potential with distance. This dV by dl indicates rate of change of potential with distance. Also, dV by dl is maximum if cos theta is equal to minus 1. And cos theta is minus 1 when theta is equal to 180 degree. Therefore, dV by dl max is equal to E. The maximum value of dV by dl is called gradient of phi. So, therefore, gradient of phi is equal to dV by dl max. Then direction of gradient is opposite to that of field. Therefore, gradient of phi is equal to minus of E. Gradient is denoted by del V is equal to minus E, and you can represent it as a E is equal to minus of del V. But in terms when you are speaking, you have to mention it as E is equal to minus of grad phi. So the next relation between E and V. So this is a very simple derivation. You can derive easily. Let potential phi be given in Cartesian coordinate system phi x, y, z. Then incremental potential dV is given as. Here in Cartesian coordinate system we have studied point P is located at x, y, z. Here potential phi is denoted in Cartesian coordinate system as x, y, z. Therefore, potential dV is given as dV is equal to delta V by delta x dx plus delta V by delta y dy plus delta V by delta z dz. Then in Cartesian coordinate system, electric field intensity vector is denoted as Ex cap plus Ey cap plus Ez cap. Any vector in terms of A bar, B bar, we can represent, that is A bar is represented as Ax cap plus Ay cap plus Az cap. Similar to E bar is represented like this. Okay, then differential length in Cartesian coordinate system. For Cartesian coordinate system, differential length is given by dx ax cap plus dy ay cap plus dz az cap. But we have dv is equal to minus of edl. So e bar is in terms of this, e bar is this like this, ex ax cap plus ey ay cap plus ez az cap, and differential length dl is this. Put these values in this equation, we'll get this equation. So this is the equation. Take dot product, that is ax cap dot of ax cap is a 1, ay cap dot of ay cap is 1, and az cap dot of az cap is a 1. Therefore we'll get in this equation ex dx plus ey dy plus ez dz. We'll get this equation. Then compare equation 1 and 5. So compare this equation 1. So this is the equation number 1 and this is the equation number 5. If we compare these equations, that is this equation we have to compare with this equation. Okay, so if we compare, we'll get ex is equal to this term, that is this dx, and this dx gets cancelled. Then ey is equal to this term. Okay, so ex, that is in terms of negative. Okay, here negative sign is there, therefore ex is equal to minus da by phi by da by x, ey is equal to minus dv by dy, and ez is equal to minus of dv by dz. So putting all these value in above equation, we'll get, that is the equation 2. Putting all these value in this equation, that is ex, ey and ez, fill up those values. After filling those values, we'll get such a type of equation, that is a minus da by phi by da by x ax cap plus minus da by phi by da by y ay cap plus minus da by phi by da by z az cap. So take common here, take here common, negative common here, and also take phi common outside. This phi is taken common out, so we'll get term da by x x cap plus da by y ay cap plus da by z az cap into phi. But if you recall, what is this term? This term is a del. Vector operator del is denoted by this. But in this, if we deriving relation between E and V, this term is denoted by gradient. Del is denoted by gradient. Therefore, as this term is a del whole term, then E is equal to, we can write minus of grad phi, or E is equal to minus of grad phi, means this term is denoted by gradient of phi. So in exam 6 to 7 marks, derive relation between E and V, or prove that E is equal to minus of grad phi. Okay, such type of derivation is asked. So recall steps, practice it, and you can solve in exam. Then gradient in different coordinate system. So in Cartesian coordinate system, gradient phi is given by da by phi by da by x ax cap plus da by phi by da by y ay cap plus da by phi by da by z az cap. And in cylindrical coordinate system, gradient phi is given by da by phi by da by r ar cap plus 1 upon r da by phi by da by phi a phi bar plus da by phi by da by z a z bar. And in spherical coordinate system, gradient phi is equal to da by phi by da by r ar cap plus 1 upon r da by phi by da by theta a theta cap plus 1 upon r sine theta da by phi by da by phi a phi cap. Okay, so if problem is asked in Cartesian, then you have to use this formula, and in cylindrical you have to use, and in spherical you have to use this formula. So if point coordinates of point P are given as x, y, z, then use this formula. And here, for similarly for cylindrical coordinate system, r name is r phi z, and here in spherical coordinate system, you know the coordinates of point P, that is a r, theta, and phi. So we will take one problem on this gradient. If V is equal to 3x square minus 5 plus 3z, then find potential, electric field, and flux density at point 3 minus 2, 4. So we have given V is equal to 3x square minus y plus 3z. Thus potential at point is given by 3 minus 2, 4 is that is put the values of this x, y, z in above equation. If we put the values, 3 into x square, x is a 3 cube 3 square, minus y is minus of 2, fill up here, then z is 4. So according to that, fill up 4, we will get v is equal to v at minus 3, v at 3 minus 2 4, we will get 41. Then electric field intensity is given by formula E is equal to minus of grad V. So fill up that formula, then find the partial derivative of each term, that is the delta V by delta X. So to take partial derivative of this equation with respect to x, with respect to y, with respect to z. If we take it with respect to x, here we will get 6x. And if we take it with respect to y, we will get minus 1. And if we take it with respect to z, we will get 3. Okay, so E is equal to, we will get this equation. Find E at 3 minus 2 4. Put the values of x, then y, and z. That is here we have to fill up the values. So 6 into 3x cap minus ay. Here no any coefficient of y. Then next is 3az bar. So 6 into 3, you will get minus of 80x bar minus ay bar plus 3az cap volts per meter. Then next they have asked find the flux density at point 3 minus 2 4. So flux density formula, we know that d bar is equal to epsilon 0 e bar. Here epsilon 0 is the permittivity of a free space, and we know that epsilon 0 value is 8.854 into 10 raised to minus 12 farad per meter. And put that value only, that is put the value of e bar, this value we have to fill up in this equation, and multiply this, and you will get the value. Okay, if we want to find the magnitude of d bar, then make its coefficient square, that is 18 square, then minus 1 square plus 3 square, and by calculating calculate by using calci, you can find out value of magnitude of d bar is 161.81 into 10 raised to minus 12 coulomb per meter square. So this is one of the problem. They ask if this problem is given in Cartesian coordinate system, therefore we have used this gradient formula. If problem is given in cylindrical, we have to use cylindrical coordinate system gradient formula. For spherical, we have to use spherical gradient coordinate system formula. So coordinate system part is very important. Then next problem we will take, if phi is equal to 100 sine theta upon r square, and point P is located at 245 degree 30 degree, that is from this we can identify the coordinate system 245 30 degree. What is coordinate system? That is this is r theta phi, two angles and one point is a r. So this is a spherical coordinate system. Okay, that is a r theta phi. Point P location is given I like this. That means point P is in the spherical coordinate system. Now we have the equation del V in the spherical coordinate system, that is del V is equal to del by V by del by r a r bar plus 1 upon r del by V by del by theta a theta bar plus del by V by r sine theta d phi a phi, or 1 upon r sine theta del by V by del by phi. Here del by is required, not d phi. Okay, a phi bar. So del by V by del by r, find out the or take partial derivative of v with respect to r. If we take partial derivative of this equation, that is 100 sine theta upon r square with respect to r, then we will get equation, that is 100 sine theta upon r square. This 100 sine theta keep outside, and 1 upon r square you can find, that is value of that del by v by del by r, will get minus 200 upon sine theta r cube. Okay, we will get this value, that is 1 upon r square will get after partial derivative we will get this value. So you can solve it and see whether this value is you are getting or not. Then dabba v by dabba theta. With respect to theta, we have to take partial derivative. Therefore, sine theta partial derivative, it is a cos theta. Therefore, 100 cos theta upon r square. And dabba v by dabba phi is equal to 0. Here, if you observe this equation, there is no any pi term. Therefore, dabba v by dabba phi is equal to 0. So, fill up all these values in this equation. What is the value of dabba v by dabba r? Minus 200 sine theta upon r cube. Put the value plus 1 upon put the value 1 upon r dabba v by dabba theta. What is the value of dabba v by dabba theta? 100 cos theta upon r square. Put the value. This value is fill up here. Okay. Then next putting r equal to 2, theta is equal to 45 degree. Find e. We have to ask uh, this potential v at this 245 degree 30. Therefore, EP is equal to values r is equal to 2 in this equation. Therefore, it becomes 2 cube. Okay, minus 200 sine 45 2 raised to cube. Theta is a 45 degree. Put value is only 1 half 100 cos of 45 upon 2 raised to square. Calculating with the help of calc, we can find this value, that is minus 17.67 AR bar plus 8.83 A theta bar. And if we take its negative, we will get this type of a equation. So very easy problem. So according to main, in such type of problem, first we have to identify this coordinate system is very important. And according to coordinate system, how to find coordinate system? By location of point P. So those students who have not attended the coordinate system part, revise it, attend it, previous video lectures you have to attend, then you can understand. Okay, so find the coordinate system, or which problem is given in which coordinate system, then according to use formula for gradient. Okay, and only take partial derivative in that case, partial derivative, and fill up values. And if they ask at this point, fill up those values in that equation, and we'll get answer. Okay, so in this lecture we have taken potential gradient. So this we will stop here, and the next lecture we will take another topic. So in notebook you have to solve this derivation, and try to practice it so you can recall in exam. In this subject, um, you can understand partially, but if you not practice the derivations problems, then in exam it is difficult to recall the derivations. Only 2 to 3 lines are recalled, and you you are in burden that time. Okay, so make practice from day one, you can score this subject. Okay, up to last one batch, one student up to 94 95 marks he has taken out of 100. And also in same 28 29 marks maximum students have got. So if you practice and daily and work hard, you can score this subject. Subject is interesting. Okay, thank you, we'll stop here.